there? Would you just like that? Come back.
All right, let's make sure we got our phones way in focus here.
They brought everyone back. Yeah, I know.
What do I do on the far left, Drake?
What?
What do I do on the far left there?
Add four.
Very good.
Go.
How about the right one here, Hunter?
Line greater than 4.
Right, divide by 2. Was this a conjunction or disjunction? Disjunction, right? When it's or, it's a disjunction, which means the graph will 99% of the time go away from each other, right? Opposite. Hello. Yeah. Oh. 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 So it doesn't work. Okay. All right. Want to figure out something else. Okay. All right, good. Thanks for calling. All right, bye. All right, so does this go both opposite ways? Yeah, it does. And again, it won't be 100% of the time, but like I said, 98% of the time, it will do that when it's a disjunction, an or problem. Autumn.
I made 2 different graphs. Can I just do that?
Now, put them on the same graph, please. Okay? So we have 2 ponds, but we are going to use 1 graph for it. Okay? Abigail?
So with these junctions, if they would be toward each other, would it be like one, they would face the same way, or?
Well, sometimes they might go the same way, and sometimes they might go towards each other. There was actually a homework problem, I think, that you had one that they both went to the right. One of the last ones, I think. It was like from 3 or something, or -3, if I remember right. So if you have an or and they're going the same direction, it'll be the one farthest left. And then that, if it's going, that to the right, it would be this one. If they were both going to the left, we'd go from the 4 that way. Yes. Did I answer? Okay. All right. This one, there was one like that on the homework. Liz, what'd you do on the left side of this one? Close. Well, you gotta remember, if you divide by a negative. Good. Remember to flip. Your inequality, we divided by -7. And then here we'll subtract, and what do we get, Grace? Right, and this is a conjunction. Usually those go towards each other the majority of the time. Again, not every time, but a high 90%. So -3 here, and then -2, and then -1. So we have, it's open, why? Because it's not equal to, and this is closed, because it is equal to, right? Greater than -3 would be this way, less than -1 is this way, so they end up going towards each other. So that's the graph of that one. Yeah.
We're looking at the conjunction, you always connect them, because you just said like 90% of the time, it usually happens.
Yeah, we'll just connect them if they're going towards each other. If they were going away from each other, and it's an and, what's that telling you? Yeah, there's no solution, because there's nothing that works for both. For this to be true, it's the numbers that work for both. Any of the numbers that I would pick in this area work in both of those. When it's an or, it can work in one or the other to be true. Okay? Any other questions? Is that helping some maybe questions you had? Okay. So we did, what, 2, 3, 4 to start? Is that the ones I gave you?
Yeah.
Okay. Number 2, it's a disjunction. They end up going opposite directions. X is less than or equal to -3, or X is greater than 4. So in your graph, a solid dot at -3, arrow to the left, an open circle at 4, arrow to the right. For number 3, it's a conjunction. It does end up going towards each other. There's 2 ways you could write this. You could write X is greater than -2 and X is less than or equal to 6, or you could write this. Just do one statement like that. That's the same thing. So when we graph that, we have an open circle at 2, a solid dot at 6, and then connect them like this. Number 4, that was the one that went the same direction, wasn't it? You add 2, you get 3, and then you divide by 5, you get 5. So they both go to the right. X is greater than -3, or X is greater than or equal to 5. So when you graph that, it was +3, right? Or was it -3? Okay. And it just takes care of the +5. We'll just call that 0 then. So it just, if you want to get technical, all you would have to have is this part, the open circle at 3, and an arrow to the right, because that takes care of the ones from 5 on. But if you had both of them going, that's fine. I'll give you credit for that. Then we jumped to 14. So this one is X is less than -3, or X is greater than or equal to 5. So we have an open circle at -3, arrow to the left, and a solid dot at 5, arrow to the right. 15, X is greater than or equal to -1, and X is less than or equal to 5. A solid dot at -1 and 5, and connect them. Any questions up to 15? Okay. I want to look at 28 and 30 because some people weren't quite sure what to do there. So there's a picture of an inequality on the graph. So we're supposed to write the inequalities. So we had a solid dot at -5 going to the left, and we had an open circle at 3 going to the right. Okay? So this is an or problem because they're going opposite directions. And then you just write X is less than or equal to -5. X is greater than 3. That's all. Okay? So if they go opposite, you're going to put or in between. If they go towards each other, you're going to put and in between. In 30, they go towards each other from -2 to 6. Okay, so this is the graph. So it's X is greater than -2, and X is less than or equal to 6. So that's what we were supposed to do for those. Questions? Simple, right? Okay, so today we're going to talk about absolute value problems. Okay, so yesterday we called them compound inequalities, right? Well, absolute value problems are like compound problems. There's more than one problem. There's two of them, even though they only write one. Okay? So absolute value, how many problems are you going to have to write? Two. Everybody say it. Two. Okay, Garrett?
Yep.
All right. Remember, absolute value means, these straight lines mean absolute value. It's the distance from x to 0 on the number line. It's a distance. If I drive from here to Uniontown, let's say it's 3 miles. That's positive 3 miles, right? When I drive back here, is it negative 3 miles? No, it's still positive 3 miles, right? So it's just, think of it as a distance. So that's why the answer, or an absolute value, should always be equal to a positive. It says because absolute value represents distance without regard to direction, it's non-negative or positive. Okay? So again, the absolute value of 5 is 5, the absolute value of negative 5 is 5. They're both 5 units from 0 on our number line. Okay, it says absolute value equations and inequalities can be represented by compound statements. So our first equation is the absolute value of x equals 3. The solutions of this are 2 points that are 3 units from 0. Okay? Positive 3 is 3 units from 0. Negative 3. So there's 2 answers. So the answer to this would be x equals 3 or x equals negative 3. Because when I substitute 3 or negative 3 in here and take the absolute value, what do I get? 3. All right, so there's 2 possibilities. That's why I write 2 problems. Okay? When it's equals like this, it's always a disjunction, an or. When it's equals. Okay? All right, this is less than. All right? It says the solutions of the absolute value of x is less than 3 are the points that are less than 3 units from 0. The solution is a conjunction, an and a problem, when it's less than. Okay? All these numbers from 0 up to negative 3, not including negative 3, that distance is less than 3, right, on that side. And all the numbers that I could pick in here, up to but not including 3, are also less than 3 units from 0. So there's a bunch of numbers that we could put in there, right? An infinite number. Okay, so less than, and. Greater than? Is an or. So equal and greater is or, less than is and when you write your 2 problems. Okay, again, the absolute value of x greater than 3 are the points that are more than 3 units from 0. All right? So if I take the absolute value of any of these numbers, I get a number that's bigger than 3. More than 3 units away. Absolute value of any of these numbers, same deal. They're more than 3 units away from 0. Going opposite directions, disjunction, it's an or problem. Okay? That's a way to remember. Usually we say greater is ER. Just think of it as greater, and less than, add a D to it. That's how you can remember what kind it is. Remember, equals is or. So you're going to have a couple that are just equations, and you won't have to graph those answers. And then the others you'll do the graphs for the greater or less than. Okay, again, or and or. And if you use less than or equal to, greater than or equal to, the same rules apply. And, or. All right, so what are my two problems? Hannah, write my two problems for me. Pass, that is not an answer. Unacceptable.
I don't know.
Okay, you can't say that in court. Mrs. Miller wouldn't let you say pass. You can say what? Oh, the fifth. You could say that, that's good. Cole, you wanna help her out?
I plead the fifth.
Oh, I thought you guys are tougher than this. All right, I'll do this first one. Autumn, go ahead.
Okay, wait, you want me to solve it?
Well, don't solve it, just tell me what the two problems are. Well, let's go back for a second.
I don't even know how to solve it.
All right, look at this. They got rid of the absolute value part. Did they change the absolute value part?
Oh.
No.
Okay.
What did they change?
Negative and net.
Right, they just changed A to negative A on the other one, right? The only thing that changed. So,
Negative 3.
well, don't try to solve it, just tell me what the two problems are. Drop the absolute value sign.
Negative 3 plus k is 10.
That's one of them, what's the other one?
Positive 3 plus k.
No, that doesn't change.
I don't know.
What's that change to?
13.
Negative 10.
Oh.
That's all you gotta do. This is a mistake some kids make because they're not paying attention at this point, Gabe. Yeah, Gabe. Well, just now you were looking down, so I just picked on you, okay? So this part does not change. Negative 3 plus k on both. The only thing that changes is that number to negative, okay? But every year I get kids that'll change that to 3 minus k. You don't need to do that shit. Just over here. Now, when you do these, it has to be absolute value of something equals a number. There can't be any other numbers on this side outside of the absolute value symbol. If they are, what are you supposed to do with them? Move them over first. Okay? So from here, you're just going to add 3 to both sides. Hannah,
Why does the 3 just become positive?
because you're changing the problem here. See, we're taking the absolute value of this whole thing. So we can't change that 3. Okay? Absolute value is 10 units from 0. Well, what's the other number that's 10 units from 0? Negative 10. That's why we got to write that one. So that will never change, that part. So we're just adding 3, so we get 13 and negative 7. Right? Okay? When it's equals, you don't have to worry about doing a graph. Just on the inequalities. Okay? Ava, what's my two problems?
You take away the absolute value, and then when the 4 change at all, and then everything else, it would be x over 4. I don't think we changed the last one, so minus 6 equals positive 6. No, alright,
Close.
close.
Hunter,
Do you have to do the 6 over first?
yes.
Oh, okay. I
I
forgot.
Remember, this has to be alone before we write our two problems. So we're going to make it equal to what?
Negative 8.
Nope,
Positive.
4.
And then.
Now we can write our two problems. X over 4 equals 4, or X over 4 equals negative 4. Okay? You getting the idea? And then from there, what am I going to do both sides? Multiply by 4, right? So we get 16 or negative 16. Autumn.
Do you have to do that when you're like not, right, just solving the inequality?
If there's no absolute value sign, we don't have to do that. We only have to write 2 if there's an absolute value.
So every time there's an absolute value, you have to get the stuff, like the stuff on the outside to the side first.
Yes.
Interesting.
And then, how many problems are there? 2. Once the problems are there, we know what to do, right, to solve. Just remember, there's 2 solutions. Okay? If we put 16 up, not what I wanted to do. If we put 16 here, what's 16 divided by 4? 4. What's the absolute value of 4? 4. What's 4 minus 6? Negative 2. What's negative 16 divided by 4? Negative 4. What's the absolute value of negative 4? 4. And then what's 4 minus 6? Negative 2. So there is 2 numbers that I can plug in for x to make that work. Okay? All right. What's my 2 problems? JR?
X plus 9 equals common 13, or X plus 9 equals greater than 13.
Right.
And then, yeah, one of the cons of the equation would be versus 22.
No, because you're going to subtract, right?
Oh, wait,
This one will be, but not 22, it'll be, yeah, negative. And this is,
that one is that one is positive 4.
right.
So,
Okay?
the rate is
Questions? Getting the hang of it? Okay, let's look at inequalities then, with absolute value. That one we have to do what first? Plus 8, then go from there, right? Okay, so,
question.
sorry, Adam.
Okay, so wait, can you go back one?
Sure.
So for that one, we like for ones like those, yeah, we have to write them out, you have to solve them as well.
Yeah. Then you solve it. After you write them both, you solve them both. Okay? So it'd be 5 and negative 5 when we finish, right? You want me to finish that one?
No, it's okay, I know what I'm doing.
Any questions? Other questions? All right, all good questions. All right, so this, same rules. Isolate the absolute value if you have to. If there's numbers with the absolute value outside of it, take them to the other side. Rewrite it as a compound inequality. If it's less than, you're going to put a what word between them? Less than and. If it's greater or. Then you're going to solve just like we did and graph. All right? So my 2 problems are negative 4q plus 2 is greater than or equal to 10, or negative 4q plus 2 is, think about, we changed it to a negative 10. Basically, we divided by negative 1. What do we do with that? Flip the sign. So you got to remember to flip the sign also on the inequalities. There's 2 things you got to change. The number to negative and switch the direction of your inequality symbol on your second problem. And then from there, it's just like yesterday, right? That's why we did yesterday, type problems first. Subtract 2 and divide by negative 4. Okay, so what's going to happen here when I divide by negative 4? That's going to flip again, right? Oops. And what's going to happen here?
It's gonna flip again.
Flip again also. Okay? So Q is less than or equal to negative 2, or Q is greater than 3. This junction on our graph, it should go opposite directions, and it does. Okay? Audrey, you ready? What do I do first?
You're gonna solve it to add the voice. Good.
Good. We got to get that 36 over first. Some of us get going kind of fast and then we forget this little step. Alyssa, now what?
3x is less than 24.
Yeah, what, and this was the other one, is that what you're telling me?
Yeah.
Is it and or?
4.
That's what you said? Okay. So, let's go ahead and do that. What do we do to both sides?
Divide by 3.
Divide by 3. You guys all okay with that? Okay, so let's check it. What's 3 times negative 8?
24, negative 24,
Negative 24. What's the absolute value of negative 24?
24.
24. Plus 36. 60, is that greater than 12?
Yeah.
Okay. So, let's try, oh, it says I can't use negative 8, why? Why can't I use negative 8? It's not equal to, so I gotta use another number. How about negative 7? What's 3 times negative 7? Negative 21. What's the absolute value of negative 21? 21. What's 21 plus 36? 57. Is that bigger than 12?
Yes.
Oh, okay. Let's try less than 7. 7 would work, right? Well, that works. Everything works, huh? Let's check. Well, I guess if I graph that, that's what I wanted to show you, I guess. Greater than 8 would be this way, right? Less than 8 would be that way. What do we know if they go towards each other and it's an or? Anything works. Couldn't we tell that right from the start? How would I know that from the start? Mary, what do you know about absolute value? It's always positive. So if this side is always positive, and that side is what? Negative. Will the positive always be greater than the negative? Yeah. So if you recognize, Drake, Derek, if you recognize that you have an absolute value greater than a negative, it's always going to be what? All real numbers. Anything's going to work. Okay? You realize that you can not worry about doing all this and just say all real numbers. Okay? If it's all real numbers, you don't have to graph it. Okay? But it still worked out that way when we did all the work too. What do we do here? Multiply by 3. You understand that 3 is not in the absolute value symbol? You guys see that? Sometimes they'll have the 3 in there, but it would have been all the way down, okay? This would have been extended down, then the 3 would have been in there. I wouldn't have had to multiply both sides by 3 first. So there's my 2 problems. We okay with that one? Then from there, you know what to do, right? Questions? There's the answer. All right, how about this one? What do I do first? Kendra? Good. But what do we like to do instead of dividing by a fraction? multiply by the reciprocal. So we're gonna multiply by -2/1 instead. So Kendra, what you said is not wrong, but we like doing it this way instead, don't we? Isn't that easier than dividing by a half? So those cancel out. I get the absolute value of p minus 2 is greater than or equal to, oh, what do I gotta remember? I gotta switch the sign, why? Because we multiplied by a negative. Remember, it's not just divide, it's also multiplied by a negative. Okay? So let's not forget that. Okay. So, Gary, what's going on?
Hi.
What's going on here?
Everything.
Yeah, everything.
Yeah.
Catch up with us now.
I am.
What are my two problems?
P minus 2, we're gonna do, y center equals to 6, -6, and then the other one's the same thing but +6.
And, why is it an and?
This is less than.
Oh.
Very good. You guys see anything going on here? Look at that original problem that after we multiplied by -2. What's absolute value?
Positive.
Positive. Will a positive ever be less than or equal to -6? Remember, this is always what? Positive. Will a positive number ever be less than or equal to a negative? No, so what's going on here?
No solution.
No solution. Okay? What's gonna happen is when we graph those, and it's an and, they're gonna go away from each other. They won't have anything in common, so there's nothing that works for both. So look for those. When you see a negative on this side, check this. If it's greater than, it always works. If it's less than, it never works. Good job today.
Oh. I don't know, but you were smiling, so
How could you tell she was smiling, Gary? Oh, she got those smiling eyes, huh?